In the last video about percentage yield, we spoke a little bit about waste and how the chemical industry wants to avoid waste products. Waste is inefficient, and one measure of how efficient something is looking at percentage yield. That's what we did last time. In this video, we're going to look at atom economy, but we'll talk a little bit more about waste just to start with, because this is the page in the book that introduces atom economy. So the chemical industry wants to avoid waste because it's inefficient and can cause pollution, and at the end of the day it costs them quite a bit of money. We've got three reactions here that we'll have a quick look at. Three reactions. We've got iron oxide reacting with carbon monoxide to make iron and carbon dioxide. Iron, obviously the useful product here. So the question says, explain which of these processes has no waste products. Well, in number one, the waste product is carbon dioxide. Now sometimes people think carbon dioxide isn't something to worry about because it's a gas, it goes into the atmosphere, therefore that's not a problem. Of course, we know that carbon dioxide causes global warming. And there's some really exciting stuff in the news at the moment about carbon capture technology and turning carbon dioxide into useful products. So the industry is trying to get around that. And that's one way that the industry tries to work with waste. It tries to turn their waste products into useful products. Because that way the waste doesn't go into the environment, and that way they can actually sell more stuff and hopefully make more profit for themselves at the end of the day. But number one, there's waste here. The carbon dioxide is waste. Number two, electrolysis of brine, salt water. So we've got sodium chloride here, and this is electrolysis. Now when we electrolyse salt water, sodium chloride, salt that's been dissolved in water, of course we've got the hydrogen and the hydroxide ions in the water here. We get a mixture of products. So the chlorine is produced, hydrogen is produced, and sodium hydroxide is produced. Three products. Now you may think there's waste there, okay, but that's not the case. No waste, as all products are valuable. All these products are used in industry for different things. Hydrogen, rocket fuel, I suppose, things that take the space shuttle up into the sky. But actually we're also talking about hydrogen-powered cars, and there's certainly hydrogen-powered buses in London now. Chlorine, used for making bleaches, things like that. Sodium hydroxide, used for making ceramics. All three very, very valuable products. Actually, sodium hydroxide is possibly more common, as used as unblocking drains, caustic soda. Very good for unblocking showers, things like that. Number three, production of ammonia. Nitrogen hydrogen makes ammonia. Now you may think there's no waste products here because there's only one product, but of course don't forget this is a reversible reaction. The Haber process. This is the Haber process, of course, for making ammonia. The Haber process is a reversible reaction. So as the nitrogen hydrogen make ammonia, the ammonia reacts with itself to make nitrogen hydrogen. So actually, the product, the ammonia here, is mixed with nitrogen and hydrogen, and what they do at the end of the process is they separate the nitrogen and hydrogen out, and you may just think, well, they just let them go. They don't. They put them back into the start of the process again to make more ammonia. So in the end, they do get used, but there's no 100% product in a reversible reaction here. Okay, so it just gives you an idea about waste. The idea of the industry is to minimise waste. So this is the only true waste product, I suppose. This one here has no waste products. This one here is a reversible reaction, so the reactions need to be separated and recycled. Anyway, one measure of efficiency is atom economy, and we have to do a calculation about this. So we've got an example of how it works here. We've got this reaction, methane plus water makes carbon dioxide and hydrogen. This is steam. Steam is blasted at the methane. It splits it into hydrogen and carbon dioxide. And that's how we make the hydrogen for the Haber process. Right, so it says, calculate the atom economy for making hydrogen in this process. Well, there's our hydrogen there. Okay, so what we're looking at with atom economy is how much of the reactants are turned into useful products. That's a useful product, this is waste. Carbon dioxide is waste. So what mass of the reactants are turned into the useful product hydrogen? Okay, now to do that we have a formula. We have to learn all these formulas. Always have to learn the formulas. And what we're going to do is we're going to look at the mass of the desired product. Well, the products are on this side of the equation, so we're only interested in the right-hand side of the equation here. Okay, so the mass of the desired product, so we need the mass of the hydrogen, okay, in this reaction. Now, notice it doesn't say the formula mass of hydrogen. We don't want the formula mass of hydrogen, we want the total mass of hydrogen on the right-hand side here. A lot of students get these wrong because they give the formula mass of hydrogen, not the total mass of hydrogen on the right-hand side here. So for atom economy, it's total mass, the mass of the desired product, divided by the total mass of all the products. So on the bottom, we need the mass of the carbon dioxide and the mass of the hydrogen, because we're going to what we want to do is we want a percentage of the useful product. So we need the total on the bottom with just the useful one on the top. So working here, to do this, we're going to have to work out the formula mass of hydrogen. Formula mass of hydrogen, H2, there's 2 hydrogen atoms there, so each hydrogen has an atomic mass of 1, so 1 plus 1 is 2. Okay, but it's the total mass of the hydrogen. Now we've got 4 hydrogen molecules there. 1 hydrogen molecule weighs 2, so therefore 4 is going to be, 4 times 2 is 8, that's why we've got 8 on top here. Okay, now total mass on the bottom, I've got 1 carbon dioxide molecule. Okay, so that's the formula mass of carbon dioxide molecules worked out here. 1 carbon is 12, and oxygen is 16, so it's 12 plus 2 16s, 12 plus 16 plus 16, 16, so 2 oxygens, 44 in total. Now in total mass of all the products on the bottom, so I've got 44 plus the hydrogen, the 4 hydrogens, 8 on the bottom there. So that's going to be 8 divided by 52 multiplied by 100 equals 15.4%. Now that's a pretty shockingly low atom economy. Okay, chemists probably aren't going to like this process that much because best part of 85% of the atoms that go into that reaction are waste. So that's a low atom economy. And let's have a quick go at one of these down here, and then I'll leave you to do the rest on your own. Let's look at this one. Calculate the atom economy for making lithium hydroxide. Okay, remember, we're not interested in the reactants, we're only interested in the products. Okay, and there's our lithium hydroxide. So lithium hydroxide, that's the useful product. So it's the mass of desired product. I've written from the equation to try and encourage you to think we need the total mass of from the equation. There's 2 LaOHs there. Okay, mass of desired product from equation divided by the total mass of products. So not reactants, total mass of products. We're going to multiply it by 100. Remember, always write out these formula. Okay, for every example you do in the book, write out the formula because it just gets the formula in your head. You learn it that way. Work smart, not hard. Okay, it takes a fraction of a minute to write that out, but it gets it in your head a little bit further, and that way you can do it when in an exam later on when you're under a bit of stress. So the mass of desired products, right, so we need to work out the formula mass of lithium hydroxide. 1 lithium, 1 oxygen, 1 hydrogen. Lithium is 7, hydrogen 8, well 1 plus 7 is 8, plus the 16 of the oxygen there, so 8 plus 16 is 24, so that's 24. Now, this is the mass of desired product from the equation. Now I've got 2 lithium hydroxides, so I'm going to need 2 times 24 there on top, okay, because I've got a big 2 for lithium hydroxide. The stoichiometry there is 2, and we need the total mass of lithium hydroxide. Okay, so on the bottom, I'm going to have the 2 times 24 again, okay, plus H2. Now there's no big number before that, so it's just simply 1 plus 1 is 2, because 1 hydrogen molecule is 2. Okay, and then multiplied by 100. Okay, just rationalising those numbers a bit, 2 times 24 is 48. That's going to be 48 plus 2 divided by 50. 48 divided by 50 times 100. That's going to be 96%. So that atom economy is very, very high. Okay, chemists would like that. Well, they wouldn't like this one, that's too low. That one's very nice, that's nice and high. So this is a measure of efficiency, how much waste there is in the reaction.